which is so this so Austria, every measurement that we took, we found it that Austria had a GDP that was higher than the European mean. And then when you sum up those entries, it becomes 12, right? If you want to normalize it, what you can do it is that you can divide it by 12. But if you divide it by 12, then you already know how many columns are in your data. But most of the time, we do not know how many columns there are. So what we will do is, remember that I showed you the command called data.columns, right? So if I go down here and if I do data.columns, it gives out a list. And what I can do is I can measure the length of this list by doing this, right? And it will give me the number 12. So there is something called hard coding, which I have done here, but that's not a good idea. What I will do is that tomorrow, if we are working with a different kind of data, but the same format, it might have different columns. So if I compute the number of columns on the go, it makes my code better suited for the world usage. Okay. So if you want to see nicely structured, so this is the output that you're getting. And what is happening is that we know that Greece, for example, 33% of the times that you observed the data, it had a GDP that was higher than the European average. So let's look at another country. So for example, Turkey never met it. Switzerland always had a higher GDP. Sweden always had a higher GDP. Italy, half of the time it was higher, half of the time it was lower. So these are the kinds of measurements that you can extract from your data analyses. All right. So are we all good? I know it's getting slightly tricky, but this is being recorded. I'm guessing the organizers will share the recording, so feel free to go back to the recording and like do all of these exercises again. But for now, if you have any questions, please unmute yourself, ask. I will be happy to explain something again. So any questions, anyone? Is everything good? Can I get a few thumbs up? Okay, one thumbs up is still better than no thumbs up, so I'll take it. Oswald, Maurice, Raymond, Zire, Maya, all good? Does everybody understand everything? All right. So now we're going to introduce a few more commands, and then we're going to take a break. So, or actually one more command, basically. So you notice that we calculated this column, right? So this column is good, but it is, I mean, it may be informative in certain ways, but in some other ways, it is not very informative. So what I want to do is I want to create groups of countries, for example, or where I want to see how things are going. So what I'm going to do is that this entire command, I'm going to refer to this as something that they have called the wealth score. I'm going to save it on a variable, right? And I want to delete this. And I also want to delete this, right? So now remember, so what is wealth score? Wealth score actually works on a mask, correct? So wealth score took mask.higher.aggregate and then computed some metric, which I just showed you. So what I can then do is that I can use something called group by, which comes as a command with data frames. And what you can do is that you can provide a mask that you've just calculated for this, right? So if you just do this, this is an object, so you can't directly access it. But because you did not get an error, that means that it has been calculated. Now there are different. So if I do dot followed by tab, it will show me an autocomplete. And in this autocomplete, there are many things which can be done. But I'm just going to take you down to some. And then we're going to just do this. So if you look at this, what has actually happened, actually maybe I should just display the wealth score as it is, so we have a better idea what is happening. So remember that what are the values that are in here? So the kind of values that we are getting is 0, 1, then 1 is repeating, then zeros are repeating, then 0.5 is a new unique value. So by the time we get here, we have 3 uniques. We have unique 0, unique 1, unique 0.5, and then another one, unique 0.3. So in this entire list, there are only 4 values, right? Those 4 values are 0, 0 0.3, 0 0.5, and 1, right? 4 unique values. And what is happening is that from my total data, I am going to sum up for those where this criteria is met. So for example, 0.33 is met for Spain, Slovenia, Ireland, Greece, right? And so only for those countries where 0.33 is met for 1952, you will sum up the total their GDPs. Does that make sense? Do you want me to repeat it? Remember that in our table, we have names of countries, and then we have 12 columns, one column for every year, or not every year, every 5 years, there is one column. And then in each column, each country's GDP for that year is listed, right? Then what we did was we wanted to find out which of the countries had GDP higher than the European average and which had GDP lower than the European average, right? We calculated that using just this, right? So then we created a mask, and then we applied that mask to actually find out that across the in that complete row for every year, did Austria, for example, perform better than the European average or worse than the European average, right? And that gave us this new mask, right? And then we found out that we can make groupings, right? And then we grouped the countries here. And then these countries that are reflected by their wealth score, I'm summing up their uh, GDPs, the 12 columns, right? Now, you might find this very tricky to follow, but remember that as a data analyst using Python, you may have different requirements. You may not need to do these steps and do them in exactly this order. What I am trying to demonstrate is that you can analyze your data in many different ways. One of those ways is to create masks. Masks are true false subsets of your data where the values are following your criteria and when they are not. If they're following your criteria, that value becomes true. If they're not following that criteria, that value becomes false. Using this true false mask, you can get values back from your original data and then manipulate them. And we are on this journey of manipulating those values. Okay, so we have demonstrated here that we have used the group by command. We have grouped by these values. I told you that there are 4 unique values. Those 4 unique values are listed here. And then for the countries which obey those 4 values, which obey that value, so there are a group of countries which are 1. So this one is 1, UK, Switzerland is 1, Sweden is 1, Norway is 1, Netherlands is 1, Iceland is 1, and like many more. So all those countries which have the value 1, their their GDPs are going to get summed up. So this 104,317 is a sum obtained by adding all the countries' GDPs, which are shown here as 1. Okay, I hope that makes sense. So now what we are going to do is I'm going to do a check how many people are actually doing this as I am doing it on Jupyter Lab. Can you please raise your hand? Because depending on how many of you are doing it, if only one of you is doing it, it does not make sense to actually do the exercise. You can do that at home if because other people are not doing it, right? So how many of you are doing? If only one of you are doing it, I will probably skip and I'll go to the next part, which is going to use, which is we were going to look at plotting.
I'm doing it on the terminal IPython 3 because now my network is giving me a problem, but it is working fine.
Okay. So what I'm going to do is I'm going to skip the exercises for now. You have the links to these exercises and you have their solutions, right? So in these, I would highly recommend that you do these exercises because they will help you understand more. In this exercise, they will post a question, and then if you expand, click on this arrow, they will tell you what the solution is to get to get an answer, right? So we're not going to do this right now. I am going to stop this section here, which is this basically section was about data frames, getting access to values, and then running some other functions on those values or masking them to analyze them. So in summary, what we did was we looked at the iloc and the lock command. We saw how they worked. We used the function describe. We looked at transpose. We looked at info, and these were very basic functions. Then we moved towards creating masks. We created a very simple mask where we only add one number applied to the entire table or a subsection of the table. And then we had a second mask where we had one value per column. And we use that to address certain questions. All right. So this completes actually two of the sections of pandas data frames. The third section actually looks at generating plots. So I'm going to take maybe a 10-minute. It's been a 1 hour session since we came back. So let's take a 10-minute break. It is 4:50 at my end, and we will come back here at 5 o'clock. Okay, so in about 11 minutes. So for those of you who want to take a break, please feel free to go ahead. If you have questions, Ken should be here. Nikita might be here. You can drop them in the chat. And yes, so South African time, you should be back here at 11, right? And then we will do one quick session on plotting. And then we will move to if conditions and for loops, and then we will call it a day. So hopefully after you come back from the break, in 1 hour, we will try to sum up everything. So I will see you all back here at 11 a.m. South African time. Thank you so much. All right, people, welcome back to what will probably be the last session. We're going to spend like about an hour 15 minutes doing three things. The first thing is we're going to look at how to make figures or how to make plots. So obviously there are many different kinds of plots. And what you can do is you can obviously, depending on the data type that you have and what is it that you want to show from your figure, you will choose the kind of plot that you want. But in today's session, we will demonstrate some very basic principles about plotting. There are several libraries out there. I will be making use of one of the libraries, but obviously you're welcome to explore as many libraries as you feel comfortable. So like I told you in the beginning when we started using pandas, just like we imported pandas, we are also going to import another library called matplotlib. Now, a library can have a lot of things. Maybe for some reasons you don't want um, all the functions in the library. Maybe you want a subset of those functions. And if you know what is the container containing the subset of those functions, you can specify here. Uh, so this command right now will not bring in the entire matplotlib library, but only a subset of it, right? And again, you notice that if I leave this as it is, every time I have to use the command from here, I will have to retype the whole thing again. So this is where aliasing will come in very handy, right? Now, depending on your setup, you may or may not get a warning, right? So I get a warning here saying that because I have not set it up to work this thing, it has done something. But if you get a warning and not an error, it is okay for today's exercise. Okay. So can I check with a thumbs up how many people are following along, doing it actually? Oswald, Ali. All right. So if people are doing it, they may or may not see the error, may or may not see the warning. This is a warning, right? An error would be a lot more explicit and would actually tell you that something is broken. But if it just pops up like this, it's okay for today's exercise. So now what we're going to do is we're going to generate a very small data set, and we are going to use basic plotting to actually plot it. Okay, so what I want you to do, and hopefully the plot will come out, but sometimes you may have to run extra commands to actually, uh, while the plot is created, but it is not displayed. So to display the plot in this window, you may need to run extra commands. I will tell you if they are needed. Let's see if I can. So to generate any plot, does not matter what is actually going to be on the plot. If the plot is two-dimensional, then you need an x-axis and a y-axis, right? So you need to put some data on the x-axis and some data on the y-axis, and then the relationship between them will be displayed by the graph, right? So let's arbitrarily create three time points. Actually, 4 time points. Let's call them 0, 1, 2, and 3. And let's create another list called positions. And let's just say that they are at 100, 200, and 300. Oh, sorry. So what I basically want to do is I want to see the trend. I can already see it because the data is quite simple. So as the x-axis is increasing, the corresponding value on the y-axis is also increasing. So this will be a straight line, which will be at an inclination of 45 degrees rising up, right? Not 45 degrees. Anyway, so it will be an inclined line going up from the origin. So let's try and plot this. So if I were to just do PLT, which is the alias of the library here, and if I want to just create a very simple plot, I will have to specify two things. The x-axis first. So on the x-axis, I want time, and on the y-axis, I want position. If I run this, I get this very simple, this graph is basically useless, but the idea here is to demonstrate to you how to generate a graph, right? So to generate a graph, you need three things. Well, you need a couple of things. One is you need the right library and the right function. You need something to be put on the x-axis, and you need something to be put on the y-axis. So 0, 1, 2, and 3 are points on 0, 1, 2, and 3. And on the y-axis, you have points 0, 100, 200, and 300. You may ask that, hey, we never provided 0.5 and 50. So why is the line, is there a point here? Because it's a straight line, it does not show where exactly the data points are, right? So if you want to create those data points, not just the line, you can do O, for instance. If I run this, it will show me now, instead of drawing a straight line, which does not tell me how many data points are in my data, I can display it like this. Now you will notice that the first point is at 0, 0. The second point is not at 0.550, it is at 100. So the second point here versus the second point here, then 2, 200, and 3, 300, right? So I'm just going to remove this for now. This was just to demonstrate. So we're back here. Now, most of the times, if you are publishing scientific data, you want to tell the user or the reader what is on the x-axis and what is on the y-axis. So for that, you will have to use two more commands. You will have to do x label. And on the x-axis, we want time. And on the y-axis, we want position. Okay, simple stuff. X label puts whatever you put in here down here, and Y label puts whatever you do here, here. Okay, I hope everyone is clear with this. There are no, can I get a few thumbs up? Thank you. Okay, also put title. So if you want title, then there is a command. It's actually not in the material. So this is the title, right? So normally scientific figures do not have titles. So I have never seen a scientific, good quality scientific paper. They do display X, they do display Y, but the content of the figure, the best practice is that you usually put a caption underneath the figure. You say figure 1, and then the first line should display the title of the figure, right? And then the next line should actually explain what the figure is showing. Okay, but anyway, you wanted the title, so you will have the title here. And then obviously there are other commands which we're not going to go into, which controls the size of the font, the shape of the font, the coloring of the font, whether the font needs to be horizontal or whether it needs to be vertical. You can, so in this graph, 0.5 and 50 are not part of my data. So you can actually control whether you want 0.5 and 50 to show up on the X and the Y axis or not. And you can use something called X tick frequency to control the X ticks or X ticks labels. There are various ways, depending on which library you're using. You can actually control how many points are displayed and on the X and the Y. So the confusion that comes in from, say, we do not have a point here. So do we have a point here? No, we don't. So if you don't display this, then the user will automatically see what is happening. Then there are commands to actually, if you want inside the, this is just one line, right? So when you have one line on your data, you probably do not need a legend. But if you have multiple trends that you want to show on the same figure, then you probably want to differentiate between them, that the blue line represents speed of the trend for the truck, and the red line represents the trend for a car, right? So then you can have legends inside the figure, which actually color code the line and show what is happening for what. But for now, I just want you to see that the plot command creates a plot. The X label and the Y label in the title put the X label, the Y label, and the title. All right. So very simple stuff. Now we are going to not use this fake data. We are actually going to go back. So I'm just going to crop this out. I mean, cut this out. We're going to do this. I am going to go back. Actually, I'll just go back up here. I will import. Actually, because I have not shut down my Jupyter Lab, the import pandas that I ran in the previous one, which I've deleted, is still loaded in the memory. So I do not need to write it again, but for the purposes of consistency, since this will get recorded, I just want it for the record that you want to put, when you're writing new code, do not expect the older libraries to be there. Just load them up again. So we're going to do this. So now I have imported the library matplotlib, and I've imported pandas. So now I'm going to use pandas to read, just like I did before, pd.read_csv followed by the path of, let me see what they are reading. GDP Oceania. All right. So, and what we're going to do is we're also going to do index underscore call equals country. And yes. So I'm going to read in my data and mount it to the variable data. Now let's, I told you that pandas comes with a lot of power, right? So what we're going to do now is we are going to recall or remind ourselves what the command data.column does, right? So if data.columns, if you put it in, it will display all the 12 columns. All right, we just did that. If you do str in front of it, what will happen is that it will convert it into an object where things will be in a string format. All right, but obviously you will see the will not see it here. So what I want to show you basically is that now what we are going to do is we are going to strip. So remember that our column names have unnecessary characters. So if I do data.columns, right? Notice that every year, this 1952 is a meaningful number, but this is repeated. GDP per cap, per cap, per cap. So what I'm doing here is I am going to separate GDP per cap underscore from all entries in my, like this. Okay. So if I print this out, notice that each of these are still in its same place, but this has been stripped out and only the year label remains. Okay. So now I'm going to call this as years. All right. So just for consistency, let's print it out as well. So the years variable has all the years inside it. All right. So now what we want to do is we want to look at data.columns, right? Again. So data.columns gives you this. Okay. And what we want to do now is we want the columns to be replaced, right? So what was data looking like? So if we do this, data looks like this table. Data.columns gives us access to the column headers, which gives us this. But I want to overwrite this. I want to change the column names from what they were to this. Okay. So if I just do this, and now if I look at data, oh, sorry, what is happening? If I now look at data, notice that the column headers only show 1952, 1957, not GDP per cap 1952. Okay. But I also want this number to not be a string. Why do I know it is a string? It is a string because I can see it here written in inverted commas. So what I will do is that I will show you a command that if you print out years, it prints it out like this, but you can change this data type using as type, and then you can specify what type you want. So when I print it out like this, notice that it is still the same value. The only difference is that it no longer has inverted commas in front of it. I can also change it to a float, right? But showing 1952.0 has no meaning, right? So I will choose to save it as int, but I want these numbers up here to be int. So I will put this back up here as type int. Do this, do this. You will not see a difference here. But now if you call data.columns, it will show you them as numbers. All right. Okay, so now we have prepared our data set. And what we are going to do is we're going to do plotting on this data. So what I want from all of you is to give me a thumbs up if everything is okay. If you want me to repeat something, please unmute your mic and ask. Thumbs up or questions, please. Those are your two options. So thumbs up if there are no questions. If there are questions, please unmute and ask. Maurice, okay, 2 thumbs up. So 3 thumbs up. So we have Ellie and Maya. So Ellie, you're with us?
Yes,
All
I'm
good?
here.
Okay.
I'm,
Any problems? Anything you want me to repeat?
I'm still on the ears. So I think, yes, I'm here, there, on 119.
Yep. Right.
Okay.
But do you have problems?
No problem at this point.
Perfect. Perfect. All right. That's good. So so what we are doing right now is we are restructuring our input data to get it into a shape where when we do the plotting part on this, our life becomes easy, basically, right? This entire exercise is about making our life easier. So when we now what we have done is that we have restructured our data so that the column headers are mathematical integers, and and basically we have row identifiers as the name of the country. All right. So now let's go back and use the command data.loc followed by Australia. So who's going to be brave enough to tell me that when I run this, what will it show me? Can anyone tell me? We just did this a while back. We used the command lock and iloc. So iloc was using mathematical numbers and lock was using country. I mean, lock was using strings, the country and the column, the row and the column identifiers. So what do you think will be displayed on the screen when I run this command?
I think it will
Anyone?
display the row Australia.
That is perfectly correct. So for each of the, so it does not show it in that order, but yes, you are right. 1952, 10,000, 1957, 10,000, and those values are listed here. Okay. So now that we have our data, what we can do is we can just plot it out, right? But one thing to remember is that when we plot this out, it looks like this. Okay. So I would like to remind you of one thing. When you are using plot, and before plot you had PL or PLT, that plot function was coming from the matplot pyplot library. We are currently using PD, data frame, LOC, and then using plot. So this plot is not this, well, it is the same, but basically you did not need, if you wanted this, you did not have to import matplotlib, right? This is a function built into pandas because remember I told you that pandas is designed for data analysis. So it wants to portray itself, or it wants to come off as a self-contained library, right? So while plotting can be done outside, but plotting can also be done inside on the using the plot function available inside pandas. Does everybody understand that? Any problems, any issues, or is everything good? Can I get a thumbs up if everything has made sense so far? Thumbs up. All right, 4 thumbs up. That's good. Okay, so now what have we done? We have taken our data. We have taken the column headers, which had a fixed word in them, GDP per cap underscore. We removed that word, leaving behind only the year label. What we did after that was we took that year label and it was a string and we converted that into a number. Now, why did we have to do that? The reason why we had to do that was that if you put on the x-axis a string 1952, the library will not know what to do with it. But if you put a number 1952, it is a mathematical number, so it will have a significance when you put it on the x-axis. Your smallest number is 1952. Your largest number is 2007. So then the graph, then the program will automatically know that I'm only going to display the range between 1952 and 2007. It still does not know that these are years. It just interprets them as numbers, right? So 1952, next one is 1957, 5 years apart, but the same distance is going to be kept between those. And then it generates a plot like this. Okay. So again, we are going to now look at that instead of just plotting the data, we can do some transforms and then plot them. All right. So, and also in comes a slightly tricky situation now. So up till here, we're all good. Data dot T. Can someone tell me what will happen if I do data dot T?
The data
Someone
on
people?
x-axis is going to be on y-axis, and the one on y-axis is going to be on x-axis.
Yes, so it switches the orders of the rows and the columns, right? So in the columns you had GDP and in the rows you had countries. So now that will be flipped. And what will happen is you will get something like this, right? So yes, you're absolutely right. So we're going to use the built-in function called plot. And remember that this time we had two columns to plot, right? We previously had two columns, but one was in years, and pandas knows that they are column headers, so they will always go in the x-axis, right? And the Australian GDP values, that was one column of data. This time when you did data.t, it automatically plotted two columns. One is for Australia, one is for New Zealand, and it did it like this, right? And now it automatically knows that because there are two columns, it will know that it needs to color both of the lines differently, and it will automatically generate the legend. All right. So now somebody previously asked as well that how do you add labels, titles, and stuff. So for label addition or any modification to this figure, you will need the matplotlib library. And we are now going to use plt dot, just like we did before, ylabel, and we will do GDP per, oh man, GDP per capita, right? And you will notice that on the Y, the axis, the label appears. All right. I hope everything is clear. I hope it is. All right. So what you will also see is that in some cases you may not like this graph because it might not tell you the right kind of, it might not display the right kind of information. So what you can do is you can bring in new styles, right? So if I were to change this graph, for example, I can bring in a new style, right? And for example, a very popular style for, especially for people who use R, is something called ggplot, right? And ggplot comes with its own presets. So what we're going to do now is use that style. And so if I just do ggplot, you will notice that the background has changed to gray, right? But the line graph is still the same. So line graph is default behavior. If you want to plot a different kind of plot, then you will have to go in here and do kind equals bar, right? And now your charts are different. So remember that you previously saw two lines. You saw the Australian line and you saw the New Zealand line. So the Australian line was going through the tips of these red points, and the New Zealand line was going through the tips of these blue bars, right? So if you think that the line trend is not acceptable, because if we go back to line, for instance, if I remove this and if I do this, now you don't know exactly that in 1990, I mean, you do know that there is a difference, but
Sorry to
this.
Sorry to interject you. I just interested when you say on the first line plots style use ggplot. Is the style different? You have different styles, or is that one is only the style that you can use, or there are different styles than
There are many
GG?
styles available. Okay, so let me actually take a 1 minute break. I'm going to go look at the Python manual and bring you back a list of styles, right?
Okay.
So,
Okay.
so I'm actually Googling this right now so that I can actually show you. So if I do pyplot style use, you will find this hit. And so, okay, so these are for reference purposes. Obviously, you will have to look at each one of them and find out that if you want to create of this style or of this style or of whatever style, you will need to find the right keyword, right? So for instance, style use. Let me just show you. Okay, hold on.
No, okay, I can see now. It's like if you are familiar with
Yeah,
group
yeah,
plot,
so
yeah, it's like a
yeah,
group
yeah,
plot.
so
Actually, you
yes.
can use plt.style not available and then print, enclose that in a print.
Okay.
Then you can get the style.
Thank you. So what is it? plt.style not available. There you go. Thank you, Ken. So we are using ggplot, but there is grayscale, there is classic, there is, well, yeah, so there is a lot of other stuff. So Seaborn is a different library, just like matplotlib is one library. Similarly, Seaborn is another library. If you are not working inside pandas, you will have to import both of them separately to get their functionality. But when you are working in pandas, because it's a collection for data analysis, it brings everything in one place. And you have styles across the board for usage. Thank you, Ken, for this. So I actually just use matplotlib, pyplot for my conventional plotting. So I'm not very familiar with Seaborn, but Ken is apparently. So if you have any questions, feel free to drop him a message. But obviously, if you don't, because I did not know this command available, so I went into the styling, the help menu or the documentation. So that is one way of doing it. But if you, with passage of time, if you keep using it, you will learn the commands, and then you no longer have to do this. All right. So is everyone familiar with? So we did the ggplot. We did the kind equals bar. Now each style use will come with a different kind of plot that you can make, right? So you will have to connect the two to make sure that it works. All right. So yeah, so at this point, we are, let me see if I can find some other useful things here. Okay, so we have already linked this content to your website where you actually saw the schedule. And in this, we have some other, because we're short on time, I would like to spend some more time on if conditions and for loops. So we're just going to leave this as an exercise for you for doing it later. But this is basically just telling you different graphing styles. So you're still doing data dot t dot plot dot scatter, and instead of getting a line plot, you get a scatter plot, and then you have some exercises here, and you are also given their solutions, right? So feel free to practice, and if you have any questions, I think Nikita should have placed my email or Ken's email on the website. So we will be happy to take any questions even after. So let's suppose after 2 weeks, you suddenly start deciding doing this, and then you have questions, you can always come back, and we will be happy to help you out. So at this point, what we are going to do is we are going to take a 5-minute break. I'm going to open this to questions again. If anything is not clear, feel free to ask. If you want me to repeat anything, let me know, and I will happily repeat it, because now we're moving to the last two parts of the Python workshop. One of them is using for loops, and the other one is using conditions, right? So what we are going to do is we're going to go through them. They should each take about 15-ish minutes, maybe 10 minutes. Oswald, did you raise
Sorry.
your hand?
Yes, I remember you said that the column, the x-axis and y-axis, it only takes numbers. Is there a way that you can put in strings? Because there are some cases where the
Yes,
graph.
yes, you can. Yes, you can. So there are many ways of doing that, but one way is that you create two arrays. One array holds which numbers are on the graph, and the other array holds what you want to replace them with. So when you generate the graph, you will generate them with the numbers, but then you will replace those numbers with the values in the second array. Right? And then when that will happen, there's an example here as well. So let me show you that just for your reference. Oh no, this is for loops. I think I closed that. Hold on. Sorry, just bear with me for a second. Plotting. So, okay. So we were looking at this. So people, the question is that instead of having numbers here, how can we get text? So text you can get by doing, where did that go? Is it this one? Yes. So for example, your question is like this, right? So on the x-axis, you want to show the entire string. It can be anything, right? So you make the graph using, Oswald, this is what you were asking, right?
Yes.
Yes. So the code to actually generate that would be right here, right? So they are not using the method that I just told you, but what is happening is that you will load your CSV file like we have done. You will, from that, you will get the minimum and you will get the maximum. And then you will just do and get the rotation. So because this is pandas, it will automatically handle that for you, right? But if you were using my method, the one that I just told you, I use that a lot with NumPy calculations, right? So there I generate the graph with the first array, and then I replace them with the second one using xtick params command, right? And what that command does is, let me see if I can show you from the xtick params. All right, so these parameters, what can happen is you can actually control, okay, maybe not in this one. Let me see if I can find one where they have. So this is where they're controlling the direction, the length, the width, the color, the grid. And then of course there are, okay, hold on. Let me see if I can actually find one core example to show you. Yeah, I think it's set x tick label. All right, thank you. So in here, Oswald, can you see this? Thank you, Ken, for directly sending this link. So what you are doing is that you are generating this graph, and you are putting frogs, hogs, bogs, and slogs in the. So you generate the x-axis first, and then you generate another array which is going to replace these consecutive so what you do is that you first generate the plot using x and y, and then you use the xticks command to take the original x and replace them with the labels. And then the rotation vertical actually makes them like this. If you don't leave it, it will become default and they will be written horizontally. Oswald, does this answer your question?
Yes, it has. Thanks.
Perfect. So there's a question by Ali about sharing on the workshop. So you guys have the, I'm told that you guys have the website. So in the website where it says the schedule, you can actually click on those and it will take you to the notes that we are following. or actually the course content. It's not exactly notes, but yeah. So Ali, I hope that answers your question. We are
No,
now.
I know that we can follow online, but I'm asking actually if you can download them and read them after, so as maybe print them, something like that.
I think you will have to save the web page. I don't think you can export them directly. So this is, for example, one of those. I don't think it shows, but if I do Control P, for example, I can print it out.
Okay, pages. Okay, one by one or all pages.
No, it will print out 6 pages. And then you can set
Okay,
whether you want them in black and white or in color or front and back or whatever.
cool.
So that's a printer setting, right?
Yes.
So
Thank
depending
you.
on which printer you're connected to. Oh yeah.
Okay.
So Ken also says that you can actually press Control P and then at the bottom here, click PDF. So
All
if you
right.
click on PDF and then
Save
you
as
can save
PDF.
it as PDF. And then you can print the PDF if you want to.
Okay, cool. Thank you
All
so
right.
much. Okay.
Okay, so now we're going to quickly go through loops. Actually, maybe we should go through. No, okay, loops it is. So a lot of times what happens when you are programmed. So actually, I'm going to remove all of this now because we are onto a new section. Okay, so what do you mean by loops, right? Sometimes what you want to do is you want to run the same command for 10,000 times, for example, right? If you want to write the same command 10,000 times, you have to use for loops because for loops automate code for you. Otherwise, what you will have to do is you will have to write that line like 5,000 times or whatever times you want to specify. Okay. So we're going to start off with a very simple example. I am going to create a list called A, and in that list, I'm going to put 3 numbers. Or maybe the numbers are going to be 200 and then 13. Okay, so I've created a list. A equals whatever. And then if I print it out, it looks like this. So how do you write a for loop? So in for loop, there are 2 very important sections. One section is where you write the syntax for the for loop, right? When you are writing the for loop's first line, you have to take care of 2 things. The first thing is that you need to have something called an iteratable object, right? So what does that mean? An iteratable object is anything which has an index. Think of it like this. So we had a list, right? In a list, if there are 3 entries, then the first entry has the index 0, 1, and 2. So this thing is iteratable. If it is iteratable, then I can iterate over it. So iteratable means that one after the other, I can do things on it, right? So if it allows me to do that, a list is exactly like that. So I need the iteratable object and I need the iterator. So iterator is going to be that object which is going to iterate over those things. So the basic syntax becomes for I. It can be anything, but I'm going to choose the word I. It could also be Ashar. It could also be Ken. It can be anything. For I in, right? And now I'm going to put A. So what is A? A is a list, which is an iteratable object. And then I can go one by one over all of those entries. All right. So then I must end it with a column. Okay. Now, here is one thing which we have not talked about in the 2 days that we've been talking about this is that Python is an indented language. So what do I mean by indented? It means that when you go from here, you must have some kind of gap, either 1 space or 4 spaces or a tab or multiple tabs, but then it has to stay consistent. So when you're working in Jupyter Lab, it will automatically put some space which will remain fixed for the body of the loop. But you have to have space, right? So what I can do is I can do print I. So what will happen is that the for loop will run many times, and we will find out how many times will it run. And every time it runs, I will have a new value, right? So if I am going to run this, it will put out 3 values. The first time when it prints I, it will print out 99. The second time it runs, it will print out 200. The third time it will print out 13. Okay. Is everyone clear on this? Any problems? Okay. Now, what code could I have written to produce something like this? I could have done print 99. I could do print 200, and I could do print 13. If I run these 3 lines of code, I can produce this same result. But here you will notice that I am accomplishing this in 3 lines. So I needed 1 line to create my array. Then I needed 2 lines to actually run my code. But the utility of for loops comes in handy, because now if I introduce, all of a sudden I have, let's say 15, 1, 153. So let's suppose I have this array. So now all of a sudden you have to write 1, 2, 3, 4, 5, 6, 7 lines, but your for loop body is still 3 lines. Okay. So in order to produce, and most of the time when you're working with data, you have to apply thousands of operations on thousands of things, right? So here it is 1 line. What if I had to do B equals I plus 1, and then I had to do C equals B divided by 2, and then I print out the value of C. So then it becomes 3 lines for each one value, right? So in order to repeat that, I would have to write this 3 times this many times, right? So for loops can help you condense code into, so that you only run it once, but because it is running in a for loop, it will run many, many, many times. Okay. So this is where the utility of for loops comes in, right? Now there is another kind of loop called the while loop. Let me see if we have that in the teaching content. I think we do not have while. Sorry, hold on. Yeah, we don't have while. So, okay, while I will explain after we do conditions. Okay, so now what we have done up till here is to use a for loop. The for loop requires an iterator and an iteratable object. So the array is the object on which my I is going to go one at a time. All right. So what other things can I do to this loop? Right. I don't have to declare it as a variable. I could have directly copied it and pasted it here, and it would have given me the same. Oh, print C. I need print I. But that's it. C. Yes, correct. Right. So it prints out. It prints that out. Okay. So the other thing that I want to highlight at this time, apart from the code condensation, is to get an understanding about strings, for example. So if I do for I in 99, what do you think will be the value here? So who's going to be brave enough to tell me for I in 99, what is going to happen?
I think it prints 99.
It prints 99. So somebody said something else. Who was that? I heard two voices. Okay, never mind. So, so Ellie says that it is going to print 99, right? The answer is no, because the integer itself, remember that when I told you yesterday, we tried picking out one of the values from the integer. So the integer is a whole number. It is not an iteratable object. A list is. So if I include this like this, then you are right, it will print out 99, right? But alone, it will not. Okay. But if I were to include it like this, what do you think will happen now? So what will be the output if I run this? So who's going to be brave enough to tell me what will happen?
Since it's a string, I think it will print 99.
It will print 99. Do we have any other votes? Who says it will print 99?
9.
Okay, so we have two votes. One person says it will print 99. The other person says it will print 9 and 9. So the second person is correct. We will have two outputs. One will be, because a string, remember, has index, right? So if you wanted to print 99 as a whole, you would have had to do it like this. So this will print 99, okay, as a string. Because the first rule is that it will go over the outside body, right? The outside body is that of a list. So the first member at index 0 will be 99. But there is a thing called nested for loops. So you can have for loops inside for loops. Okay. So what I'm going to do is I'm going to create a nested for loop for j in I. So can someone explain what will happen now? Come on. So what will happen is that when from the outside body, the array has one entry at position 0, which is the only entry that will get displayed, right? So the first time the outside for loop runs, I will get the value of the string 99. Then that will come in here. And now because the string itself is iteratable, it will print out 9 and 9. Okay. If I remove this, then the second loop will fail. And the second loop will fail because the first loop will go to index 0, pick up the number 99. But now the number does not have the iteratability. It is not iteratable. You cannot have the first 9 of the integer as index 0 and the second 9 as the integer 1, as the index 1. So that is why it will fail here. And it is showing you that 99 is integer and it is not iterable. All right. Does anybody have any questions up till now? So there are many, many ways in which you can iterate over iteratable objects. So what you can also do is, let me see if it's a part of the exercise. If it's not, we will save time and all right, so let's do one quick exercise. So here, I'm just gonna cut this out. Instead of just printing, because just printing it out is not a useful activity to do, what we are going to do is we're going to calculate some things. So what I can do is I can multiply I with 5. Then I can compute a new number, which is going to be, okay, let's make it simple so that I can actually ask you what the output would be. So, and then multiply it with 4, 5. Okay. And then print ISD. Okay, so who's going to tell me what my outputs are going to look like? If I run this, what will be the value of I when the for loop runs for the first time? Anyone?
The value of I.
So so what will be printed out when I
Okay.
run this? I want to know the final answer. But if you can
Oh.
tell me individually.
Okay, we will get I as 1, then
Yes.
following by S as 1 times 5. Then we have
Yes.
D, which will be the 5 from the S, then times 5,
Yes.
like that.
Yes. So what will be the value of I?
I will be 1.
Yes. What is the
Then
value of S?
S will be 5,
And what is the value of D?
will be 25.
Okay, so who's going to tell me for the second one? So for the second loop, I will take the value of
Next.
S.
Yeah,
So
it
who's
will
going to
go.
answer?
Okay.
No, could I please ask someone else to answer it this time? Oswald, Ali, Maurice, anyone?
If I think I'm sharing the office and someone is talking, I don't want to interfere the background.
Okay. All right. Okay, so let me just, so as we have just been told, the first time it will be 1, 5, and 25. The next time it will be 2, 10, and 50, and it will go on like that, right? So this is to demonstrate that you can do a lot of things in the code. And one other concept is that I quickly want to show is, let's suppose that you want to run this 100 times. Now it will be very stupid to keep on writing it like this, right? 6, 7, 8, 9, 10, all the way up to 100 or 1,000 or 1 million. That is not helpful, right? So there is a built-in function called range. If you use range, then you can specify a starting point and an ending point. Oh. Okay, so if I specify 0 as the start, and if I specify 3 as the end, then again, just like indexing, it will take the value 0, it will take the value 1, it will take the value 2, but it will not take the value 3. So it will go up till 3, but not include 3. I can do the same thing with 10 and 17, right? So it will start off with 10. It will go to 16, include 16, but not include 17. All right, same thing. Any problems, anyone? Anything at all? All right, so in here, the exercises are also present. And what you will see is that you are using different variations, right? So for instance, if you do for character in 10, what will happen is that character will take one value at a time. It will take the value, the first value is T, the second value is I, the third value is N. But inside the for loop, you are not doing anything with character. You are only using character to run the for loop 3 times, right? Every time the for loop runs, total will take the previous value of total, which was 0, and add 1 to it. And by the time you have completed this for loop and print out total, it will become 3. Okay, make sense? So there are much more detailed exercises here. We won't have time to go through all of these. I want to quickly cover if conditions. So if you have any questions later on when you're doing these exercises about how things are going, please feel free to email us, and we will be happy to take any questions regarding this. So remember, for loop requires an iteratable object and an iterator, and then inside the body of the for loop, you can choose to use the iterator or you can choose not to use it. It all depends on what code you're writing and why you're writing it. So that covers our for loop section. So now we're going to go to the last part, which is if conditions. Okay, so okay, so in the if conditions part, so let's decompose this. So what do I mean by condition? So sometimes there are certain sections of the code which you only want to work if certain criteria is met. So for example, if you are doing weather modeling, let's just say, and you want to make a prediction for right now, you have to check what was happening 1 hour ago, right? So you will say that if it was raining 1 hour ago and if it was too cloudy, then chances are that right now it will continue to rain. Okay, so this if checking that if was it raining 1 hour ago, was it cloudy 1 hour ago, these are called conditions which affect your outcome. So similarly in programming, you have to check certain values if they are above or below a certain cutoff, and then if they are above or below a certain cutoff, you make certain decisions, right? So if conditions help you do that. Okay, so very simply, we are going to write, we're going to create a variable called mass and give it the value 3.54. Then we are going to write our if condition, and just like the for loop, you have a special keyword called if, and then after if you have to type your condition. If mass is greater than 3, then I want to print heavy. Okay, so if I run this command, it prints out heavy. Why does it print out heavy? It prints out heavy because this command, when you solve it, becomes true. So if I were to just type here mass greater than 3, so can someone tell me what will be the output? So who's gonna unmute their mic? Yes, please go ahead.
I guess
Did you say true?
Yeah.
Yes. So the answer is true, which means that when this condition is evaluated here, the if condition becomes true, and if the if condition becomes true, then whatever is below it will get done. If it is not, then so let's change this. Let's change this to 2.54. So is 2.54 greater than 3? Who's going to answer that? Is 2.54 greater than 3?
It's no, it's not.
Yes.
It will print nothing.
Yes, that is correct. So I will get nothing in the printout, right? But if you're getting nothing in the printout, sometimes if you're like me, you'll be super paranoid. So I will always recommend that when you're writing if conditions, make sure that you cover all possible conditions, right? So if you're checking for greater than 3, then you can also include something called the else statement, like this, right? So now I know that either my code will print heavy or it will print light. If the code does not print anything, I get super scared that maybe something somewhere is broken. right? So my way of coding is to always include an else statement so that I know that if condition has not been met, right? And while this might be bad, I mean, some people might consider this bad practice, but to keep myself calm and peaceful and relaxed, I would like to structure my code this way. Okay. So then between the if and the else statement, you can have many conditions, right? So let's just say that if greater than 10, then I call it very heavy. Then I change this else if to if mass is greater than 5, then slightly heavy. And then if I have mass is greater than 2, then it is not heavy. And okay, so who can tell me what the problem with this code is? So mass can have any value, right? So I can, okay, so else print nothing. Okay, so what is what have I done wrong here? I want to demonstrate this point, right? So mass can be any integer value. At this point, it will evaluate and check if it is greater than 10 or not. At this point, it will check if it is greater than 5 or not. At this point, it will check if it is greater than 2 or not. But remember that if you have written an if else statement, if the first condition is met, the rest of the code is not checked. Okay. So a value that is like, let's suppose that I enter the value 19. Is 19 greater than 10? Yes or no?
Yes.
Is 19 greater than 5? Yes or no?
Yes.
Is 19 greater than 2? Obviously 19 is greater than 2.
Yes.
So now I have 3 conditions that are being met. And you must always remember to write the if else block such that overlapping conditions never occur. Right? Right now, this same condition, so if a value is 19, this is true, this is true, this is also true. Right? But it will only run for the first one and not the second one. So for example, if I change the order of this, if I say 5 and if I say 10, and if I run this, what do you think will happen? What will get printed out? Will it be very heavy? Will it be slightly heavy? Will it be not heavy? And will it be nothing?
Very heavy.
It will be very heavy. Why is it very heavy? Because the first condition is greater than 5, right? So 19 is greater than 5. And because 19 is also greater than 10, it never reached this part. It exited the minute it met this, the rest of the code was not evaluated. So if you have to write like this, you have to make sure that each condition does not overlap with any other condition. So to write that, you will have to use binary operators to create ranges. So for example, I will say, and mass is lesser than 10. So mass is greater than 10. So let me just write it out like it was in the previous one. Like this. So, and put equals to, and if it is greater than 5 and equal to 5, greater than equal to 5 and less than 10 and lesser than 5. Okay, so now I have conditions which will not overlap. So a value can be greater than or equal to 10. But if it is greater than equal to 10, it will come to this. Will this be true? So if let me just show you. If I have set the value of mass equals 19, then what do you think will be the answer of this? Mass is greater than equal to 5. Will this give you true or false? Is the value of mass greater than and equal to 5? The answer is yes, right? 19 is greater than 5.
It's not.
Yes, that is correct. No. So when you put the equal to sign, you give it the entire range. You say that it must be greater to or greater than or equal to, right? So this one will evaluate to true, right? But I want to contain it within the range this. So what will happen now? If I just solve this, what will be the output? Is the value of mass lesser than 10? What is the answer? It is false, right? So now if I write the total condition, yes, it is greater than 5, but no, it is not lesser than 10. So my total answer will be false, because when you put AND condition, then both the left and the right hand side must be true. Otherwise, you will get the answer as false. Okay. However, there is another keyword called OR. And if you use OR, then it does not matter. Even if one condition is true, the answer will be true. If you're using AND, both sides must be true. Otherwise, it will not evaluate to a true, right? So when I use AND here, then that means that both the left and the right condition must be met, right? So for value that is like, for example, 9, what will happen? If I do 9, 9 is greater than equal to 10. No, it is smaller than 10. So then it will check this range. Is it between 5 and 10? Then yes, this will get printed and nothing else will get solved. Okay. So if anybody is confused about this, please let me know and I will explain again. Yes, Oswald, please ask a question.
I have a quick question. Is there, don't we have a way whereby if we go through the if loop, right? Then if it's met, then instead of going to this line, you just tell the program, you know, I just skip these lines and go to this line and execute that line. There's no such command.
No, but if is doing that for you, right? So if this condition is met, then it will execute this line and not do anything else and go to the end of the code.
I'm saying, well, if is not met, right, then it's going to go to this else if, right, and then check that one. I'm saying if this is met, right, is there no way to say that, okay, after this one, just continue to this line instead of continuing to the other else if line?
Okay, I'm not sure I'm understanding what you mean, because each of these conditions will be checked until something is found to be true. If it is true, then it will run this block and not process any of these and go directly to the end. If this first condition is not met, then it will check the second condition, whether it is met or not. If it is met, then it will go to the end. Otherwise, it will check the third condition.
Okay, so if that's the case,
yes, go on.
So if that's the case, then is there a need for us to use the ranges instead, or it's just a way of putting it in certain?
No. So yes, so I'm just telling you that there is something called best programming practice, right? So with the passage of time, you will learn that if you will end up making more mistakes if your if and if else conditions are overlapping, because then you have to write them in order, right? Right now, a value that is greater than or equal to 10 should be registered as very heavy. Let's suppose that I write this condition here and this condition at the top. So right now, because I have used ranges, it is not a problem. But if I remove the range, and just do this, what will be the output? It will say very heavy. But 9 is not very heavy. 9 should have been, 9 is currently going to go to the first part, right? But if I do 19, it will also give very heavy. If I do 6, it will also give very heavy, because 6, 19, anything that is greater than 5 will trigger the first condition, and then the rest of the loop does not run. So if you're checking for something which has been exited by the first part, you will never get to the second part. So if you want to write them out of order, you have to be absolutely sure that this condition will be met for some case. But if you don't think your code through, and if you write it like this, then 6 is not very heavy. 6 is slightly heavy, right? I want 20 to give me that it is very heavy, right? But 20 is still giving me very heavy, but 6 compared to that should have given me slightly heavy, but it does not, because 6 gets evaluated here and prints out very heavy. Does that make sense?
Yes.
You have to make sure that you understand what you are doing and that you make sure that things are written in the right order, right? Because if they're not written in the right order, then things can get messed up. Okay, so I hope that clarifies the question. And so just to quickly summarize, the if-else conditions are all given in the exercise, the same exercises that I just did. They are given out in more detail in the notes. You have if statements, you have else if statements, and here they are using mass. So I was using heavy, slightly heavy. They are using examples of huge, large, and small. And then they are talking about conditions are tested once in order. I told you that. So for example, here they are giving you grade examples, right? So if the grade is 85, and if you don't write this in order, your grade is printed out as C. Why is it printed out as C when grade greater than 80 should have been B, right? The reason why it is printing it out as C is because it matches it to 70, it finds it greater, then it prints that out. So this is obviously not the grade that you get. It does not go automatically back to reevaluate. So you have to write this in a perfectly balanced order, or you can make ranges. So you can say if the score is between 70 and 80, then print out grade C. If it is between 80 and 90, print out grade B. Then it does not matter where you put it in the order, right? Because that range will only be met for one particular true condition. Okay. And then of course, they have several examples here, and then they, obviously at the bottom there are exercises for you to do. They do not introduce Boolean logic, which I have to allow you to help you make the range, but you can practice with all of these exercises. And again, if you have questions, we will be happy to address them. So at this point, we have done lists, plotting, loops, conditions. We have looked at pandas data frames, and we have looked at importing data into pandas. So there is a post workshop survey link, which I will share with you right now in the chat. It is highly recommended. It is a feedback for us, how we did as instructors. I have pasted the link in the chat. Please feel, please be compelled to actually complete this survey, so we get feedback on how we did and we can improve ourselves. Okay, so with that, I will end today's session. It has been a very long session. We've been here for almost 4 hours. We started at 2:45, right? So almost 3 3/4 of an hour. So if you have questions, if you want to discuss your own research, or if you, I have a few examples of how to use Python to do machine learning. So I can demonstrate them, but they're not a part of this exercise. If somebody's interested, please stay back. Otherwise, I think we can stop the recording because we are